Hi, my name is Richard Earl and I'm a transmission engineer here at SMT, and today we'll be going through complex planetary modelling. So to begin with, I've got a simple planetary here that I've made earlier, which just consists of a sun, 3 planets, and an annulus gear. And we can see if we go into power flow mode in 3D view, that the sun and planets rotate and the annulus is fixed. And to begin with, I'll go through a few of the settings on the planet carrier, which is the blue component, which you can see on the screen here, and then we will build up a more complex planetary system, and then look at a fully automatic gearbox example. So going back into design mode, I'm going to look at, as I said, a few of the settings on the planet carrier component. And in the properties, so I've selected the planet carrier component in the assembly tree, and in the properties tree we now have a number of options. So the first couple that I'm going to speak about are the planetary load sharing options. So there's 4 options for planetary load sharing. We have equal load sharing, user-defined load sharing, AGMA empirical or GL load sharing. With the AGMA empirical load sharing, we have an application level, and changing the application level changes the planetary load sharing factor in the properties tree below. So if we change from application level 1 to application level 2, we can see that the planetary load sharing factors change from 1 to 1.05. If we select user defined, this is then definable in this planetary load sharing factor at the bottom. So we can specify our own planetary load sharing values. Below that are the options of the planetary sockets. So we can choose to draw the planets in 2D view on the bottom or on the top. So this can become particularly useful when you have more sets of planetary gears, to hide them on either the bottom or upper halves, which can help in the 3D in the modelling when you're building up your planetary systems. So you can see unchecking them hides the component or shows it. We have the first planetary angle. So this is the angle of the first planet, which is this defined as from the x-axis. We have names, so that's just to help, which later on will help when we have multiple planets to have a good naming convention. We can choose the number of planets. We can choose the planet angles. So at the minute this is an equally spaced planetary gear set the planets are regularly spaced. We also have the planet diameter, so this is the center distance between the sun and the planet gears. And we also have then the width of the planet carrier. So this will be the width that the pin is pressed into the planet carrier. So that's the main settings for the planet carrier. We'll look at these in more detail when we look at the complex planetary system. And one thing to ensure is, based on your geometry and your planet angles, is that your gear set can be assembled. So in this example, if we change the number of planets from 3 to 4, we get a gear set which cannot be assembled. If we wanted 4 planets with these teeth numbers, we could turn off the regularly spaced planets, and then change the planet angles so that the gears become assemblable. So that's an overview of the planet carrier components for a simple planetary system. What I will do now is we'll start to build up a more complex planetary system. So to begin with, we'll have a sun, 2 sets of planet gears, and an annulus gear. And then after that, I will take that a bit further and include 2 sun gears. And then finally, we'll look through the fully automatic gearbox example. So I've started to create a new design for a double planetary gear set, and I've already brought in an input shaft, an input bearing, and a power load. So the next thing I'm going to add is the planetary gear set. So right clicking on new design, add, and gear sets. And in the gear sets options, we have a number of different ones. We're looking at the cylindrical planetary gear set. It pops up with a box to name the gear set. I'm going to leave this just as cylindrical planetary gear set. And it'll bring in some default geometry. So this has a sun, 3 planets, and an annulus again. I think there's been a couple of issues with the screen, but hopefully you can now all see the screen that's being presented. And to make a more complex or compound planetary gear set, we can add multiple sun, planets, and annuluses. So the first thing I'm going to do is right click on the cylindrical planetary gear set and add another set of planets. So to help with the naming convention, I'm going to call these, call the first one the inner planets and the second one the outer planets. I'm going to move this up in the tree just for to make it a logical order. So the sun will mesh with the inner planet will mesh with the outer planet, and the outer planet will mesh with the annulus. At the minute, there's only 2 mesh connections. So MASTA currently is meshing the sun to the inner planet and the inner planet to the annulus. So to get the gear set that we desire, I'm going to delete this inner planet to annulus mesh connection, And then using the connect component tool, I'm going to connect the inner planet to the outer planet, and we now get an inner to outer planet gear mesh, and the outer planet to the annulus. So we now have all three gear meshes in the correct with the correct gears meshing together. So at the minute it's using some standard geometry from MASTA, but I'm going to apply in the gear macro geometry mode some macro geometry and tooth numbers. So going into gear macro geometry mode and going on to the gear set design, I can start inputting some gear macro geometry. So I'm going to put a helix angle of 17. Normal module of 1.63. Pressure angle of 24. I'm going to put 27 teeth on the sun, 15 on the inner planet, 18 on the outer planet, and 72 on the annulus. I'm going to change the face widths because I'll be using this gear set in the example. In the second example, I extend it to include another sun. So to begin with, this might look a bit odd, but to save some time, I'm going to set the face width as 25 on the sun, 25 on the inner planet, 60 on the outer planet, and 60 on the annulus. The profile shift is going to be 0.5313, and the rest of the macro geometry parameters I'll leave as they are in MASTA. So at the minute, it still doesn't think this is a valid gear set, and that's because we need to set the center distances of both and the angles of both planets. To do this, I'll be using when we add the planet carrier component, we can set the center distances and first angles to create a valid gear set. So go back to the design mode. I'm now going to connect the sun to the input shaft. So using the connect component tool again and connecting it to the input shaft, and I'm going to position this so that the right hand side of the shaft and the right hand side of the sun gear align. One thing to be careful of as well, if we have only the sun selected, it's just going to move the sun gear. If we want to move the whole planetary gear set, we need to make sure that the top level of the gear set is selected. So this time the whole system will move. For the connection for the inner to outer planet, I'm going to align the left hand side of the inner planet to the left hand side of the outer planet. And I'm going to do the same for the annulus, so that the left hand side of the annulus aligns with the left hand side of the outer planet. So the next assembly that I'm going to add will be the carrier assembly. This will consist of the pin shafts, planetary gear blanks to allow the planets to rotate on the pins, and the planet carrier shaft itself. So in the design mode, I'm going to right click, add. I'm going to create a new assembly. Call this the carrier assembly. The first thing I'm going to add is the pin shafts. So I'm going to add a inner planet you have a length of 80 mil and an outer diameter of 10 mil. And then I'm going to duplicate this for the outer planets. So right clicking on the inner planet and duplicate, and then rename this. The outer planet. So we can now connect the inner planet pin shaft to the inner planet and the outer planet pin shaft to the outer planet. Can then position the shafts again using the move component tool. So for the outer pin shaft, I'm going to align the centers, and for the inner pin shaft, going to align or offset the gear 10 mil into the pin shaft, so that the carrier assembly all aligns. I'm then going to add the planet carrier component. So right clicking on the planet carrier assembly onto Gearsets and the option for the cylindrical planet carrier. So we'll select this. And at the minute it's asking for number of planets and planet diameter. So this will be 3 planets, but to begin with we'll leave it as 50 mil because this can be overridden later. And just to re-go over the options within the planet carrier options. So we have number of planetary sockets. This is the number of planets, planet pins that will be attached to the planet carrier. So in this example, there'll be 2. We have the planet load sharing options. So we have AGMA empirical, equal, user defined, or GL, which affects the planetary load sharing factor. So changing it just to application level 2 changes the load sharing factor to 1.05. We have the drawing options. So again, which of the planets will be drawn on the upper and lower halves respectively. The first planet angle of each sets of planets. The names. So in this example, I'll change it to inner planets and outer planets. The number of planets. So in this example, there's just going to be 3 in both sets of planets. Planet delta angles, so the change in planet angles. Again, in this example, it's going to be an equally spaced planetary gearset design. The planet diameter, whether the planets are regularly spaced, so in this example they are, and the width of the planet carrier component. So I'm now going to connect the planet carrier up to the pin shaft. So I'm going to, in the tree, I'm going to drag with the connect component tool selected, drag the planet carrier to the inner pin shaft. We now have to tell MASTA whether we're connecting to the pin shaft, carrier shaft. So here we're connecting to the pin shaft, and we have to tell it which of the sockets it's connecting to. So we're going to connect the inner planets to the inner planet socket. And then, again, dragging and dropping, connect the outer planet to the planet carrier. Because there's only one socket free, it's automatically connecting it to the outer socket. So now we can update the planet diameters and the planet angles. So the inner planet diameter is going to be 75, and the outer is going to be 93.75. Can now set the first planet angle. Just going to close some of these drop-down menus. So we have the first planet angle. So for the inner planets, it's going to be 0, and for the outer planets, it's going to be 40. And as you can see, when you've got two sets of planets on top of each other, the 2D view gets filled very quickly. So this is where the drawing on upper and lower halves becomes very useful. So on the lower half, I'm going to draw the outer planets, and on the upper half, I'm just going to draw the inner planets. I'm now going to duplicate this carrier component. So we've made a connection for the left-hand side of the planet carrier. We now need to make a connection for the right-hand side. And again, I'm going to connect it up in the same way as before, so using the connect component tool, dragging and dropping, again telling it that it's a pin shaft and we're connecting the inner pin to the inner planets, and then again dragging and dropping for the outer planets. And then I need to move the right hand carrier to the right hand side of the pin shafts. So we now have a connection to the planet carrier on both sides of the pin shafts. I'm now going to add a planet carrier shaft to connect to. So right clicking again, add shaft. I'm going to call it the planet carrier shaft. And I'll edit the shaft profile later to get an approximation for the planet carrier profile. A planet carrier will be definitely a component, as you'll see later, that we need to replace with FE due to the asymmetric nature. And so I'm going to connect, using the connect component tool, the planet carrier shaft to each side of the planet carriers or planet carrier components. And I'm going to position this 10 millimeters. Okay, I'm going to align the the left-hand side of the planet carrier to the left-hand set of pin shafts, and now I'm going to edit the shaft profile. To make a planet carrier component. I'm then going to add a bearing to the planet carrier. For this, I'm just going to use concept bearings. So right-clicking on the carrier assembly and adding a bearing. Again, I'm going to connect this to the carrier shaft. And I'm going to locate it in this narrower section of the planet carrier. At the minute, the gear blanks, the planet gears are rigidly connected to the pin shafts, so they won't be able to rotate. So we need to add planet carrier, gear blank assemblies to both sets of planets to allow the planets to rotate. We can do this easily. So if we click on the right-click on the inner planet, or on a planet gear set, and we get an option for create gear blank assembly. That will bring up this new window. So we have a number of options for how the gear blank is connected to the pin shaft. In this case, we need a bearing mounting, but there's also the option for a shaft hub connection. We have a number of bearings that sit underneath this gear blank. For this, we'll use one. We have a carrier bore shaft diameter. We set that to 12. A carrier thickness. This is the thickness of the shaft. Set that to 2. We can indent and offset the gear blank, but for this, we're just going to have it aligned, fully aligned. And at the bottom, we have whether we're going to add thrust or pads to either side of the gear blank. So this will add in axial clearance bearings on the left and right hand side. And you can then specify the amount of clearance either side of the planetary gear blank. So for this, I'm going to specify 50 microns of clearance. And this will automatically create the connections between the planet gear blank and the pin shaft. So we can see this is automatically brought in what we've just specified. And I'm going to do the same for the outer gear blank, so right clicking on the outer gear blank, specifying the inner diameter and the thickness. And again, I'm going to add thrust pads either side with again 50 microns of clearance. So now the Planet gears can rotate on the pin shafts. The final assembly that I'm going to bring in is a annulus assembly to ground the annulus. In this case, we'll apply an input power load to the sun gear, and the output power load will come out of the planet carrier. So again, right clicking on the new design, add assembly. I'm just going to call this the annulus assembly. And this will consist of just a shaft and a rigid bond. So right clicking, add shaft. So this will be the annulus shaft. The width of the annulus gear is 60 mm, so I'll set the length to 60, the outer diameter to an approximation of 250 to begin with, and I'll adjust the inner diameter once it's connected. Then going to connect the annulus shaft to the annulus gear. Again, I need to position this in the center. And then I'm going to adjust the bore of the profile so it's greater than the root diameter. Probably make the outer diameter slightly smaller. And then finally, I'm going to add the rigid bond to ground the annulus. So again, right click, add into couplings. Then we have a shaft hub connection. Let's call it annulus grounding. And then connect this to the annulus shaft using the connect component tool again. Because the shaft has a bore and an outer diameter, it's asking whether we want to mount or house the rigid bond. We're going to mount it on the outside of the annulus shaft. I'm going to set the length so it's grounded across the entire gear face width to be 60 mm. In the properties tree at the bottom. And then again, I'm going to position this so that the centers align. So I've already brought in the input power load. The final component that we should need to bring in is the output power load to tell MASTA where the power is exiting the system. So right clicking on the carrier assembly, I'm going to add in the drop down there's a power load, and I'm going to name this the output power load. and then connect this to the output carrier, or the planet carrier. We can view this in 3D and see that we have two sets of gears, two sets of planet gears, a sun and an annulus. And as I was saying earlier, the planet carrier shaft will be something that you'd replace with an FE component. So now I'm going to go into the load cases options and just create a load case. So selecting the second option in, we can add a load case and just specify speed and torque. Into the system, and we've run power flow to make sure that power can flow through the system. And we can animate, so I've gone into power flow mode, and you can animate this to see the sun and planet gears rotate. So now I'm going to go back to design mode and slightly extend this design to include two sun gears, and then I'll go on to the automatic gearbox example. So going back to design mode, go back to the 2D display. In the gear set, I'm going to add a second sun and call this the big sun. Call this one the small sun. And again, we need to connect, using the connect component tool, we need to specify which mesh the big sun will, or gear the big sun will mesh to. So in this case, we're going to use the outer planet. So dragging and dropping, we can tell that MASTA, the big sun is meshing to the outer planet. Going to go back to the gear macro geometry mode to specify the number of teeth and the face width of the gear. So the number of teeth on the big sun is going to be 36, and the face width is going to be 25 millimeters again. I'm going to move the big sun so it meshes to the right hand side of the outer planet. And I'm going to now create a new assembly for the output shaft. I'll name this the output assembly. And in this, I'm going to add a shaft, which will be the output shaft. Connect this to the big sun using the connect component tool. I'm going to align the left-hand side of the shaft with the left-hand side of the sun gear. And I'm going to add a bearing to support the output shaft. So again, I'm just going to use a concept bearing. And I'm going to take the power load from the planet carrier to I'm going to delete the connection between the output power load and the planet carrier and connect it up to the output shaft. Again, going back to power flow mode and running the same load case. We now have, if I just display the planetary gear sets, we now have power coming in on the small sun, going through 2 planetary gears onto the big sun, and then power coming out on the output shaft. So you can see quite quickly you can make complex planetaries, so you can add as many sun, planets and annulus gears as you require. And I'll now move on to the fully automatic gearbox, which is similar to this, but it's been extended further to include clutches, to show you how you can further model planetary gear sets. So in this example, again, it's very similar. We've got a couple of suns, a couple of sets of planets, and an annulus gear. We now have a series of clutches to load the planetary gear set in a number of different ways. So in the load case settings, in the design states, we can specify which clutches are engaged. So in each different gear, there are different clutches engaged. And as we'll see in the power flow, if we just look at the planetary gear set, if I run each of the load cases, we can see in power flow with the animation, we can see how the gears are, or by using clutches, how the planetary gear set is used in different ways. So as you can see, it can be very quick, as I said, to build up complex planetaries. If there's any questions, feel free to ask. If you do have any questions based on what you've seen here, please don't hesitate to contact our support team. I hope this has been useful to you, and I hope to hear from you soon, and in our next webinar.